Today, this is what we have here, and we want to talk about data analytics with R for beginners. And if you look at that, like I said, my name is Michael Awole. If it is your first time of coming to my YouTube channel, I am the CEO of Academic Virtual Lab, and I double as a Senior Research Fellow at the African Institute for Science, Policy and Innovation, Obafemi Awolowo University. I also have an affiliation with the University of Johannesburg. I'm a Senior Research Fellow at the University of Johannesburg, working with a chair in the College of Economics and Business. So today, this is what we want to really go through. This is what we want to examine. We're going to go through installation of R, even though we're not going to be demonstrating that. I'm only going to be explaining a few things, a few steps to getting your R and R Studio installed. And then we're going to see how to set up our work environment when you want to do any programming, you want to do any analytical, you want to use any analytical package of any programming language to do anything. The first thing you have to do is to set up your work environment. This is very important. We are going to see why this is important. We are going to see why this is necessary. And we are also going to see data types available in R. Though data types are very related in all programming languages, but the only difference is they have their own syntax, different syntax by which this is represented in R, a different way, a different syntax by which this is represented in Python and a few other ones. But then we're going to see what data types we have in R, and we're going to see demonstration of some of the syntax as well in R. And then we want to see basic operations in R, and we're going to be giving some examples. We're going to be demonstrating, practicalizing, do some hands-on session at the end of the day. I'm just going to spend like 15 minutes to do this background, and then thereafter I go to R to begin to demonstrate some of these few things to us, and then we'll be good for the day. Another one is we are going to see basic operations in R with some examples. We want to see basic operations that are variable, or operators rather, that are available in R. What are the kinds of operations you can perform in R, and the syntax to carry this out, we're going to see it as well. And then we're going to see the data structures in R, data structures, how many ways by which data can be represented in R. We're going to see that here as we go along today. And then we're going to use R to an extent as a calculator on this platform using our R environment. And then we're going to use also as a tool to solving mathematical formula. If you can solve, once you can resolve it, once you can bring any mathematical formula down to a straight line, R will be able to analyze that for you, irrespective of that formula. It could be Fibonacci series, it could be any form of mathematical formula, it could be general formula, which we call almighty formula in mathematics. Once you can express that on a straight line using our syntax, you'll be able to resolve that here. And we're going to see a demonstration of a few of that. And then we want to see how to create data frame. We are going to expatiate more on this when we get there. And possibly today, we are going to experiment how to carry out regression analysis. And if you can't do that today, in next week as well, same time, we're going to complete some of these few things. We're going to give us some more nuggets regarding how to do data analysis, data cleaning, data, and use a number of tools in R for our analysis. So let's go. The first question we want to ask is why R? I like to say here that R is a programming language for statistical computing and graphics that we can use to clean, analyze, and graph your data. So it has a number of features that it's making it to be the top notch in the society or in the community. It has free and open source tool. R is free for use. It's free for download. You don't have to pay a license for R. You don't have to pay subscription for R. It's available to you. And I can tell you the next 5, 10, 20 years, I don't think R is going to be commercialized. So that's why I recommend R for anybody for data analysis. And it's so simple, it's straightforward, it's so simple and very friendly. And it also has a large community of users. It's the latest technology, which is also competing with Python. And the platform is also independent. And then a number of other features, which time will not permit me to begin to talk about. So let's move on. There are two things you want to do when you want to use your R. The first thing is you have to get it installed on your computer. And how do you get your R installed? You have to go to CRAN. CRAN is the project website that is dedicated for R. So you have to go to rproject.org. or in the alternative, you can just do a search. You can do a search on your Google, and then ask for how to download R. You can just say how to download R programming language. If you like, you can complete or just say programming and then give it a search. So from there, you can just click on that. Once you click on that, it will show you a number of things, a number of lines. But then I can tell you that you just go to R. You can go to R Studio. If you click here, it will do the same for you. It can land you where we really want to get to. It can land you here. Okay. Okay. This is giving us the okay. So that's education. So you just watch. Yeah, you can come to CRAN here. When you say CRAN, CRAN. This is cran.rproject.org. So once you click here, the rest is so simple. If you're using a Windows operating system, you can download for Windows, or if you're using Mac, you can also download for Mac, and different other versions which can be downloaded. So here, if you are using Windows, you just click here to download version 4.31. I have already downloaded on my system. I'm not going to allow this to continue. All right, that's fine. So you just click here and you get it installed. At the same time, you can also, that's what we call IDE. IDE is a short for Integrated Development Environment, which is like an interface that will provide an interface between you and her. So that will give you the graphic user interface, a friendly interface that will give you the opportunity to interact with R, successfully. So the next thing you're going to install is R Studio. Me, I have decided to I fall in love with R Studio, so I always like to use R Studio. So let's go on. So this is showing us the progression, how to get all of that installed. You can download for Linux, you can also download for Mac, you can download for Windows, and a few other operating systems of your choice. Like I said, it's an integrated development environment for R, dedicated for R. So you can get that downloaded as well. You don't have to do any configuration. The system will do it for you automatically by itself. So let's just go on. So this is the quadrant for R. This is the interface for R Studio, rather. I can also always go back to there as well and then show you. But let me just use this to explain what all the quadrants all stands for. And normally our quadrants should start from where I have quadrant 2, but then let's just take this as it is. We're using quadrant 1 here. This is, it's like I said, it's going to give you 4 interfaces. One single interface, but like 4 divisions. The first division here that is called quadrant 1, that is where you are opportuned. That is where you can type your codes. That is where you can type your codes line by line. Like I said, let me say this, brother. R is an interpreted language. So and what does that mean? It will interpret your code line by line. After interpreting line 1, it will move to line 2, it will move to line 3, and all of that. So it's possible if you write all your lines of code in this path. So the second quadrant is where is the environment page or environment screen, where you can see all the activities that you are carrying out, that R Studio is carrying out on your behalf. Take for example now that you invoke a command from the command prompts. I'm going to show us the command prompt as well. If you invoke a command on the command prompt, you're going to see that here. Maybe you want to create an object, or you created a function and all of that. You can see it in the window here. Now the next window, you can see a kind of a chart here in quadrant 3. That is where you are going to have your graphs plotted. If you plot any graph, this is where you are going to visualize your graphs. And much more than that, I'm going to show us when I switch back to the R environment by itself. Here as well in this path, you can also okay, let me just do. Okay, this is my R window. You can also install your packages here. You can install your packages here. You can see the packages that are already installed here. You can update your packages here. All you need to do is just click on install here to install your packages. Okay, and then you can much more. You can do much more. Here as well, you can also click on help to find out the app that the app available within R. Maybe you want to find that you want R to assist you to know how to use a particular command, or what you want to find out about a particular package, what it does and all of that. You can seek for help in this quadrant. And then the last quadrant here, which is about the last quadrant here is about it. This is what we call the command prompt. In this command prompt here, what you do here is this is where you can key in your commands line by line. You can key in your commands excuse me, line by line here in this quadrant. So when you key in your commands here line by line, the system would be responding to you, and you can be viewing the results from any of the pages. Now, you can also view your result here from this place that I've just selected. You can also view your outputs here. You know, when you invoke a command from here, you can view outputs here as well. Maybe your tables, you can view it here. And then this is where you see your objects, this is where you see your functions, you know, displayed and all of that. So let's move on. The next thing here is the first thing, like I said, is to set up your work environment. So when you want to set up your work environment, what you do is, I'm going to tell you also the reason why we need to set up our work environment. When you want to save any file, you are working on a file here and you want to save it, or you want to call up a file, a CSV file, an Excel file, a data set somewhere that you have stored in a folder. You need to tell R that R, this is where I am storing my data file or data set. When you have specified that, then you will save yourself from the labor of writing the full path while you are invoking or you want to import the data set. So you don't have to do that. So the essence of setting it is what I have just explained briefly. So at the same time, when you want to save as well, you are telling her to go straight away and save in that path that you have instructed it from the beginning. So that is what you have to do. So, and what you have to do is just go to sessions here. From sessions here, you go to set working directory and you click on choose directory. I'm going to demonstrate that to us. And you click on choose directory. Then this choose directory will point you to the folder where you have to navigate to that folder where you have kept all your files that you want to save, or that you have dedicated for your activities in R programming. For me, some of the time I want to put all my works in my R. I want to put in a folder called analysis. If that is what you have done and you have saved your files there, all you need to do is just tell her this is where I put my files. And I'm going to demonstrate that to Rosie. I'm now fully in an R environment. Just click on session here and then click on set working directory. So once you click on set working directory, you just click on choose directory. So once you choose on that, you click on that, it will take you to an interactive environment where you already know what to do. You just navigate to your files there, or rather you navigate to your folder of interest here. So for me, if I want to let's say I think I opened a folder. I like to go to this folder. Let me just copy the path. The path is document match. Okay, so it's okay, that's fine. So just click on your documents here if that's where you have kept your file. Let's say I'm looking for match. I say match special. This is where I want to keep it, and I want to keep everything, all the activities I'm doing, I want to keep it in this particular folder. Or let's say for example, also I already have my files I want to use. I kept it in that folder, so I'm good to go. I'll just click on open, and if you look at here, the system will tell you that to show you the path that you have just loaded. So what it is telling you in essence is, rather than you invoking that, is giving you the code path. Yes. So it's just telling you that you can rather click or say set working directory, set wd, and then put the path for that folder here in inverted comma, yes, and then open and close brackets. So this is an alternative way to type it on the console, you know, rather than now go to where I've just demonstrated. But for me, since it's the graphic user interface, is more friendly, you don't have to, you know, cram codes. You just go to sessions, set working directories, and click on choose directory. So that way you just navigate to that directory. So let's go on. So after that, you then, now let me go to, that is that you have set that, and then you can begin to work. That's what we call packages. Packages are more or less like they are shareable collections of code and data, documentations that have been that are more or less like add-ons or extension. When R was launched out or was deployed, there are some other functions which people were not thinking about, which is giving them an opportunity to add on some extra or additional functionalities thereafter beyond the time of release of R. So that's why this is provided. You as an R programmer now that you want to be in future, you can also write packages to do one or two things, like more or less like I don't want to call them functions. They're not functions. They're more than functions. That you have written set of instructions to carry out a particular task. So everything like combined together, zipped. Let me not use the word zipped, but it's more or less like it's like a zip file that to compress together, such that when it gets to R, it can begin to carry out, to then inflate itself, to begin to carry out some functions that it has been asked to do. So most of the functionalities in R comes from packages, like I've said. I'm going to demonstrate to us. And then what you have to do is, once you have these packages, or these packages, a number of them, depending on what you want to do, because they have, like, take for example now, we have the tidyverse package. It's one of the most popular collection of packages for data wrangling, for data analysis. So, but then some of the functions in tidyverse, you cannot use it unless you have installed that package. So once you install that package, you can then little by little you can then call it into the memory of R at any point in time to initiate an instance for that package. And then you are free to use every other function that are associated with that package. And if you look at this, tidyverse now has a number of other dependencies under it. So once you install tidyverse, all of these guys will be installed alongside as well. You can also decide to install each of these in isolation. That's also possible. But once you install your tidyverse, and how do you get your things installed? You're going to look at that here. So you just type from your command prompt in R. You just type install.packages, and then when you type install.packages, you then put the name of that package inside open and close brackets, and don't forget you have to quote it. There must be an open quote and a close quote as well, and there you go. You just allow the system, but you have to ensure that you are connected to the internet. You must be connected to the internet before you're able to do this, because it's going to fetch the files, it's going to fetch those dependencies from the internet. So once you are done with installation, the next thing now is to bring it into the memory of the computer. And how do you bring it to the memory of R? You bring it to the memory by typing the word library tidyverse. You are bringing it to the memory for your use, and that's that. Now, so I move on to the main thing. One of the main things we want to do today is data types in R. Data can be represented in many ways in R, and then let us see the data types that are available in R. We have the integer data type. Integer is a whole number without a decimal point. It's like you want to measure the weight. You are using digital meter or digital, what do you call this? Or maybe you are using digital meter. Can I say digital meter? Integers are more or less like discrete values, whole numbers that does not have any remainder. It's like when you divide 4 divided by 2, it will give you 2. Or 16 divided by 8 to give you 2, or you say 24 divided by 3 to give you 8. That's whole number without any remainder. So it does not have dots, leading dots or at the preface, or at the first suffix rather. So it can either be a positive number, negative number, or 0, just like we have here. Like -4 is an integer, -12 is an integer, 0 is an integer, 3 is an integer. We also have other floating points. We have another data type which is called float. They are used to store real numbers which can have fractional parts. It can either be positive or negative as well. It can also be 0, but then it must have some numbers after a dot, like say 0.25, or say 3.14 or -3.14 or 1.0. So those ones are referred to as float points. or floating point. The another data type is string. String, you use them very well in programming language because you want to communicate with your users. Maybe you are developing a package, or you are developing a kind of a model. You want your users to understand what you have done, or you want to annotate your programs. You apparently use strings some of the time to make it interactive. Yes, and I think it's about interactivity. Yeah, that's true. So it represents textual data such as words, sentences, and all of that. But then when you want to represent them in our programming language, for example, even in other programming languages, including Python, you have to put them in inverted comma. It's apostrophe, really. Yeah, I think double quotes. Yes, double quotes, open quotes and double quotes, open quotes and double. But I want you to note one thing here. When you are writing your codes in any programming you want to do, you must ensure that you either write it in Notepad. Although Notepad may be laborious because it may not be fascinating, it may not be too friendly. You can also write it in brackets and a few other ones available. You can write it directly in R, like I have explained to you and I've showed you in that other quadrant while I was speaking when I started. So why do I say that? Because what you type in Microsoft Word, your quote in Microsoft Word will be interpreted as apostrophe, which is not the same. So if you do anything in Microsoft Word and you copy it into your R, there is a likelihood that, especially if you use the quotes, there's a likelihood that it will generate error. So you don't want to do that. Another one, the last data type here, it's the last data type here is Boolean. Boolean is a represent data type with which has only two possible values, true or false. Is it going to rain? Yes or no. But in this case, its own is true or false. So it's logical data type. Logical. Then we also have types of operators in R. Types of operators in R. So we have arithmetic operators, we have relational operators, we have logical operators, we have assignment operators, and I'm going to be explaining them one after the other with examples. So if you look at this now, these are sets of arithmetic operations you can perform in R, using the operators listed. So if you look at this, we have the addition operation, which would allow us to do to sum numbers together. Will allow us to do some additions. I'm going to explain, and then I'm going to navigate to our environment and get this done. Then you can also do subtraction as well. Subtraction will allow you to subtract one number from the other, just like we normally do manually. We also have multiplication. Multiplication in R is denoted by a star, and it will allow you to multiply numbers together. At the same time, we have division. Division is denoted by a slash, a front slash, not backslash, a front slash. So we also have exponents, which is raised to a given number of power. We use caret, just like we have here, or double star to represent exponents. Say you want to say x squared, x raised to power 2. You rather write x caret 2 or x star star 2. That's the way to represent exponents in R. Then we also have modulos, which is like the remainder from division and is represented by this has a name I can't remember now, like percentage, two percentage signs. And then integer division, we also have what we have here on the screen. So I'm going to be demonstrating a few of these to Ross, and I think right about now before I move on. Okay, let's see. Now I'm now in our environment and I want to use this. Okay, so let me try blow this up. Okay, so let's say I want to I want to put a number here. Wherever you see this sign and something like an angular bracket, not really angular bracket, I don't know what to call this, like a left elbow. Yes, if you do your left elbow and a minus all together, it represents assignment statements. It's assignment statement in R. And what is that supposed to mean? That is telling us that you can assign a value, say 5, and store it in A, in an alphabet called A, and you press or enter. So the system has taken that. You want to say, okay, I want to assign another value. Let's say I want to assign 4 into B. And I want to assign another value into A into C. You press enter as well. So the system has taken that. So when you want to see the contents of your alphabets, and mind you, when you are naming your variables in R, it is case sensitive. So if I say small a now, small a is different from what I have stored in the capital letter A. So I'm going to put 6 in this. Let me put 7. I'm going to put 7 in this small a. So the R will be seeing it differently. So what I have in big A is different from what I have in small a. So it's case sensitive. So you have to note that. So I'm going to go on. So if I want to see the content of big A, I'll just say small a and press enter. If you look at what we have here, it's telling us that it's this is stored in a location, one location. It only is stored in one location, and the value in that location is 5. That's what that is saying. So, but then that is not what I want to do. You can also say, I think you can also say print. I don't like to waste my words. You can also say print the content of A. Okay, let me print the content of small a now. It also give us that. It also give us that. But then what we want to do is to carry out some mathematical operations. Let's say we want to say capital A plus B. What do we have? The answer is 9. And mind you, and then don't forget our A is 5 and our B is 4. Let's say you want to subtract. What do you subtract? Which one is the big number? C minus let's subtract small number minus B. Don't forget case sensitivity is very important. You can see the answer is 12. But then you are only going to see this on your screen. When you come back again, you want to use it, the system will not recognize. When you have shut down your R and you have saved your, you have exit from here. But then if I were you, I will put all my values in a variable name. So, and if you want to do that, I still want to perform all of the operations. I want to add number. This is just my own coinage. This add number is my own coinage. I can say add num. It's my own coinage, which is my own, the name I have chosen to add two numbers together. So I want to add my A plus B plus C. It's going to put them in add number. Oh, sorry, I was supposed to put plus. So it's going to put them in add number. So when you want to see the content, the sum of these 3 numbers, you just invoke add num. As you are typing it, the system would just, fly it out for you, and then you can click on that. Press enter and you have your answer. That's 5. You can also say our add num, which is the total summation of all those 3 numbers. We can also say we want it to be raised to power 2. Let me use caret raised to power 2. That's 625. Then the caret also can raise to power any power. Let's say raised to power 4. It's giving us that. Then you can also say that, okay, you can also divide it by another number. Let's say C divided by small a. Let's say small a will give us 2 points. I think we did that previously. So and so on and so forth. A good number of things that you can do. So like I said, you can perform a number of operations this way. At the same time, if you want to, if you have an assignment to carry out b squared minus 4ac, for example, I'm going to demonstrate this now, and I think next week, same time, I'm going to demonstrate how to use R to solve quadratic equation using almighty formula. We call it almighty formula, but I think it's general formula. So we're going to express that. Once you can express on a straight line, R can achieve that for you. So once you have that, you can make it ready, like a kind of a package to solving mathematical quadratic formula. And that's the way to get started. As we go along in this class, in these sessions, in different sessions on my channel, we are going to be doing implementing a number of, using R to implement a number of things, purposely for different things. We're going to be getting informed as to regards what and what we really intend to do at any point in time. So let's move on. So now what we want to do now is I want to go back now. Let me go back to my PowerPoint. So that is the number of things you can do. Now we also have data structures, and I think we have data structures in R. These are many ways by which you can represent your data in R. Like I have said, we have data frame. Data frame is more or less like this two-dimensional structure you have in your Excel, if you have used Excel. Excel is where you type in a number of things you want to keep records of students. For example, you have their names, you have their ages, you have their marks in different subjects. You have so many records of students. It could be records of students, it could be records of staff, and all of that. That's where you kept them. So, and then there are a number of things that Excel may not be able to undo for you. Maybe you just want to find out, can you print, let me know the total number of students in, maybe you have a data set about running to about 30,000 students that you have keyed in your Excel. And then you just want to run to know the number of students whose ages are 25 years over. You are surprised that you still have over 25 years as undergraduate students, and you want to know how many of them. You want to check what has happened to them. What are they still doing in school at that age? So Excel cannot do that for you. In fact, even if Excel will do that for you, you have to write macros in Excel to get that done. But then R is so simple. You can import your file inside R and then invoke one or two commands, and you are good to go. We're going to see all of that as we go on. So data frame are more or less like two-dimensional structures with rows and columns, where rows stands for records. Records from left to right. Record is more or less like combination of attributes or combination of columns for specific cases. A case is more or less like the record of anybody, a record of anybody from left to right. We're going to see that example as we go on. So columns can have or hold different data types in data frame, and we're going to see example of that. I'm going to demonstrate that, but then let me say one or two things about vectors and a few others. Now we also have vectors. Vectors can be represented, they are more or less like array that can hold elements of the same data type, things that are related. They can be together. When people belong to the same family, they go together. Yes, flocks of birds of the same feather go together. So they are more or less like vectors, are things that are related. Things that are related, they go together. So we can have numeric vector, we can also have character vector. In a situation whereby we have numeric vector, it's talking about numbers that are related, not talking about real numbers and integer. No. If you want to specify integer, let us know that these are integer vector. Or if you want to represent floating points, floating numbers, let us know that these are vector whatever. So, and then we also have character vector. Character vector are more or less like apple, banana, cherry. This is an example. And like I said, when you are doing anything that has to do with strings, you have to put them into inverted quotes, and that's why we have that there. And then list, this is what we have here. List is more or less like a list can take different data types. That's the difference. List can take both numeric and non-numeric. You can treat them together as if they belong to the same family. So list can permit that. Then quickly, we also have matrices. Matrices are two-dimensional arrays with rows and columns, and then the elements must be of the same type. You can have a matrix in such a way that you want to generate matrix number 1 to 6, for example, and then you want the R to format it for you in such a way that it will be 2 by 3. This is a 2 by 3 matrix. You are actually telling R with this code to format 6 numbers from 1, 2, 3, 4, 5, 6, 1 to 6. And then format it in 2 by 3. You can also say 3 by 2. Let me see if I can quickly demonstrate that. About matrix. Okay, matrix. You want to say matrix now. My matrix. You want to say put it. This is my own matrix. You now invoke matrix here. It's a function in R. This particular matrix is a function in R. Like I said, when you are invoking any command, you have to put it in open and close brackets. So this is a function in R. So, but then the first one, matrix, my matrix, it's my own choice, it's my own coinage, that's my variable name, where I want this function to be stored in case I want to call it up again. So we just say generate number from 1 to 6 and then format it to a dimension of you can say number of row. Okay, let me know. I can use this one here. I can use this one here, but at the same time you can also say put it here 2 by 3, and let's see what that will give us. You can see immediately this thing fly up here. My matrix here, I can see it in my environment here. So if you click on this, it can bring it out for you here. You can see 1 2 3. This is two rows, 3 columns. You know, you can also say 3 by 2 as well to give us 3 rows and 2 columns. Can you say that? It has changed the orientation. So it's as simple as that. It's as simple as that. It's as simple as that. So let's go on. Now the next one here is factors. We can have factors like factor that's more or less like red, green, blue. Like you want to categorize. You want to categorize PhD, MSc, educational qualification, for example. You know. And then we also have arrays. Arrays are also similar to matrices here, matrix here, but in the alternative, what you invoke is array rather than matrix. So, but I want to demonstrate another thing here. Let me demonstrate if I have my vector, for example. Now, if I have numeric vector, say, let me know. Okay, let's put it in a container. Let's put this in a container, and then I just want to refer to. If you look at this, I want to look at the length now. Length of my number. I want to look at the length of that vector. I want to look at the length in terms of how many locations are all these guys stored. They are stored in 5 locations. So if you look at that, that means 3 is stored in location 1, 5 is stored in location 2, 6 is stored in location 3, and then 12 is stored in location 4, 34 is stored in location 5. So if I want to reference in any of the locations, I can just say, okay, I print this angular bracket and ask it to print the content of location. I can just say my num location 3. See, it's giving me the contents of location 3, which is 6. Okay, let's see the contents of the last location 5, 34. Let's say we want to just reference location 0 that does not exist. Let's see what we're going to have. It said numeric is 0. Okay, so you can see that. So that's that. Let's move on. Let us also see. Now we want to go to data frame. Assuming you want to create this data frame. You want, like I explained, this more or less like 2-dimensional array. You have the name here, you have the age here. All of these ones here from all of these things that we have on top here, we call them headers or heading of your columns, of your attributes. Now we have the name here, we have age here, weight here, height here, and salary here. So what we want to do now is for this first record, the name of the person is Aule here, and then his age is 50, and then his weight is 64.0. Don't forget that this will be a floating point, and then his height is 6.0, his salary is 130,000 naira. The second person, this is the table you want to generate. This is the exact replica of the code you are going to use to achieve that. So if you look at that, don't forget, I'm going to show you this particular student results here. His own choice file name that we have decided to use. And then here, like this is an assignment statement, like I said, and this is the data frame, the function you want to invoke to carry this out for you, because it's data frame you want to create. So you just say data.frame, and then you open a bracket and you close the same. Can you see? This open bracket, I'm closing it here. But meanwhile, I want to put all these variables, each of them like we have here, on a straight line. And the only difference is, once you finish typing the contents of the names you have for the first one, name is equal to C. C is more or less like format it in a column. even though there is no document that is telling us that C means column, but that's my own interpretation, and that's the way it does it. So because we want to do it in column by column as we have it here, so just a name is equal to C, and then if you look at this, these are strings. They have to be in quotes, in double quotes. Awole in double quotes, separated by comma. Then Diaolu in double quotes, then comma, the last name. Then at the end of the day, you have to put them in open and close brackets. And then because you are still going to write another thing after this comma must be there telling it that, oh, I'm going to the next line. Then you do that for age as well. Put it in C and you go all out again to do that. But then you find out that the difference here is these are numbers. They are integers. You don't have to put them in inverted quotes. So 50, 52, 30. But mind you, the same number of entries here must be the same throughout. We have 3 entries here for names, and we must have 3 entries here also for weight. For age. We must have 3 entries for weight, 3 entries for all other attributes you want to do or you want to compute. If you have 5 names at the beginning here for names, the age must be 5, the weight must be 5, the height must be 5, the salary must be. And you may want to ask this question: is this not too laborious? Is this the way we are going to be keying data into R whenever we need it? No. I'm just trying to show you this so that you can see that so many things can be done with R. You can apparently bring your files from external file, from a CSV that is downloaded online, or maybe that is computed from your department. They want you to analyze the result of students. Get the CSV file, put it in a folder in your R, and I'm going to show us how to open that and how to do a few things with that. So let's go on. We are not going to get to this regression today, but then we're going to continue from here. I'm not stopping yet. I'm still going to do some more. So that's what we have created here, and a few other things. So these are the regression code and summary that we can. So I'm going to move straight away now to R and begin to do some demonstration. So there are also so many ways by which, like I've said, you can bring data into your file, into your R. You can use the embedded data that came with R. Embedded data that shipped with R. And how do we get that? We get that by typing data at your console. I'm going to show you that. You type data at the console, and then it's a function. Open and close bracket has to be there. So it's a function. Just press enter. Once you click enter, it will give you a list. It must have done it. So let me minimize this. Let me move away from this magnification. So okay, you can see. Okay, let me do it here again. Let me close this. Where is it? So when you click on data, open and close brackets, and then you press enter, it will generate this list for you. These are the data sets that were shipped with R. So what that is telling us is, once you click on this double air passengers are records of monthly airline passenger numbers between 1949 and 1960 in the United States. So if you click on that, you copy that and you paste it in R here, press enter, it will generate it for you. So you can do your up arrow to see the headings, the first few, maybe the first 6. Type head to see the first 6 records or first 6 data sets of that particular data. That's what you're going to have. Now you can also check, you can scroll down to see the summary of some of those things. Formaldehyde, determination of formaldehyde. You can also see, and I think I like US arrest. US arrest is somewhere. Okay, see US arrest. It's talking about violence. That's the description here. Violent crimes rates by the US states. So it's not only in developing countries that we have, violence taking place. So they also have records for the United States. So we're going to see that. So once you click on US arrest, you can just put it there. So if you want to see the first few records, because if you want to see the first few records, you just click on enter. It will give you the first 6. You know, that is that. And then you can see the headings, you know, these are the headers. We have the murder, we have the assault, we have the urban pop, we have rape. You know, we have records for Alabama, for Alaska, for Arizona, for Kansas, for California, for Colorado. And then if you want to see the last six, which is the tail, last 6 records, you can just US arrest as well. As you're typing it, it will flip it out for you, and then you can just see that. So this is showing us the last 6 records of that particular thing folder. So at the same time, I also have, now if you now want to, you can also view it in a more friendlier environment. You want to view it like a table in a table. How to invoke a table is to say view US arrest. And before you know it, you find out that it will display the table for us in this quadrant. Okay, let's see what we're going to have. Can you see? This is more friendly. So from here you can scroll to the beginning to the end, from the beginning to the end, and scroll and have a look at what you have. Now if you look at this, we have the mother here as an attribute, another attribute, assault as an attribute, urban pop as an attribute, rape. So here you can do so many things. We call some things data wrangling. You can see, maybe you want to see the dimension also. You want to see the dimension of US arrest. Okay, it will show you the dimension, which is 50 by 4. 50 by 4 means 50 records, 4 columns. You look at that, we have 4 columns: murder, assault, urban pop, and rape. Then from there, if you want to refer to each of these attributes, this is the way you do it in R. It can be to any data. Okay, US arrest, $, press $. You can see as you press $, all the attributes will fly out. So as all the attributes fly out, you can decide to pick any one you want to reference. Now let's say I want to reference mother. I'll just click. You can scroll up and down. Let's say I want to reference mother, and you click on enter to display the contents of US arrest mother alone for you, and that's what you're going to get. So let's say I want to view that now. Let us say I want to view that. It will only display the list for me, eliminating the rest of the columns. Okay, US arrest is not displaying that. Why? View. Why are you not displaying it? Because I want it to be a better. Okay, let's see. Let's reference 2. Okay. Let me see if I can head it. Let me see. When you are typing head or tail, it has to be small letters. But it's showing us the head here. And why is it not taking the view? I don't know. Okay, I think it's seeing it like a list, like a double. Okay, that's fine. So let's move on. Other things you can do with that. It's you can also plot the graph of this. R has inbuilt graph facility, which I'm going to invoke now. So what I want to do now is let me show us the previous. Okay, this is the main one. Take for example now that I want to plot the graph, the scatter plot of both mother and assault, or maybe you want to plot everything all together. You can just say, you just press plot. Like I said, plot is a function. It has to be in open and close bracket, and then just say US arrest. US arrest. It should display it. Okay, it's so slow. Sorry. I expect to display it. That's why you don't cram things. Plot. Can you see it? Can you see the graph plot? Can you see the correlation, graphical correlation on the charts quadrant? That's the graphical correlation showing us the scatter plots, you know, for each of them. Scatter plot for each of them. So this is like 1 to 1, mother to mother, that's 1.0, and then this is like assault to assault, and all of that. This is like a what do we call it? Unit correlation, where you can then use the upper part or the lower part as correlation. At the same time, you can also plot the two of them together. Maybe any two, for example. Let's say you want to plot, and I want to select a particular two. $, mother, comma, US arrest, $, Okay, let's say assault. And there you go. That's the intersection. That's the plot of just the column for mother and the column for assault. You can also plot a line. You can plot its line by typing lines, small letters, lines, the same path, and then you can see that. But then graph is more interesting in R than what this base is giving us. We're going to get there. Visualization is more interesting when it has to do with that. There are a number of things we're still going to do. We can use a package called ggplot, but we're not going to do that today to give us more fanciful graph plots. I think we can also do bar plot. Let's bar plot the whole of the thing US arrest. Let's see what we're going to get. Must be this is not a vector matrix, so it might be difficult for us to do that. Let's do histogram. Let's try and do histogram. The command for histogram here is east. Okay, that's not, it's even also cooperating with us. Okay, let's try iris. Iris is also a package. I know it. It's also a package within R, not a package. It's a data set in R, which you can also invoke. Let's see iris. That's iris, and then let's view iris. Okay, it's bringing it here for us. Iris, when I was doing my masters, we use this iris very well, so I'm familiar with it. We have the sepal length, we have the petal length. These are the columns for iris. Let's check the dimension for iris so that we can know how many columns do we have, and then how many records. Yeah, we can see 150 records, 150 cases, and 5 columns, and that's what we have here. We can see that here. That's what we have here. We have the sepal length, we have the sepal width, petal length, petal width, and species. We usually use this one for classification modeling in R, where this species will now represent the class. You can see this is the only one that is non-numeric. All other ones are numeric. We are still going together when we are doing the machine learning aspect of R. So let's see. Very briefly, we can also let's move on. Let's move on and see other things we can do with okay, let's see. Yes, I was going to say that we can also import files through into a file that we have already saved in our folder. Take for example that we have this file in our folder, customers.csv. I have saved it. Is a CSV file, comma separated file, and I want to bring it on board in R, and I already have it in my folder which I have dedicated to be used for R, which I have declared for R when I was starting. So I'm going to show us two major ways by which you can import that file into the computer. So what we can do is to say that read.csv. Read is to read. You want to read. There is read, there is write, but in this case you want to read into R. But what do you want to read? Is CSV. So this is a function now which must be in open and close brackets. And what is that thing you want to bring in? You want to read customer.csv. Like I said, this must be in quotes. This must be in quotes. Cannot open the connection. Do you know why it cannot open the connection? We need to check what is our working directory. Get working directory. Get it for us. Where are we working from? So it means we are working from here. So which means we are good to go. But then let's now see. We want to say read CSV customer.csv. We have to be sure that our name is correct. I'm invoking customer, but meanwhile that file name is customers. It has plural. Let's do it again now. It has done it. So that's why I said R is case sensitive. So but then I will still want to also add additional features while it's importing it. I need to tell my R that I put a comma. I want to say that it has header. Those are the headings, the name, the age, and all of that, like in the other example I showed. So but then I think let me before I go on, let me view that customer now, although I've imported it, so that I can show us the example. I can show us customers okay, we don't have it stored yet. We have invoked it, but we have not stored it on the computer. We have just read it into the space, into this space, customers. Don't forget, put an S. We have to put it in a container. Let's just say my customers. So you store the output that is bringing from that external file or from that folder and store it in this R environment as my customers. Press enter. So we have that. You can see it here. My customers is here. And if you look at the dimension, it's 200 observations and 8 variables. So we can do a view of what now? A view of my customers. View my, as you're typing it to fly it out for you. So let's see, we're going to see it here. Can you see? Our file is there. So if you look at this, we have customer, we have gender, we have age, we have annual income, spending, and all of that, up to 2,000 observations. Up to 2,000 observations. So with this now, let me show you, it is also important for you to tell the computer, even though by default, it will know that it can take it as if you have instructed it to respect the heading. That's okay, this file that is coming as heading. There are some files that may not have heading. So in that case, you can, this is where to instruct it. Either it's true. You know, it can be false. But you are going to say, in this case, it is true. But if you don't have headings for your data file, you just tell it that the header is false. Then comma, what about the separators? What are they separated with? We have said that these are comma separated files, CSV. So you're going to say header is equal to, you put it in inverted quotes, comma, and then say, do you want to bring the strings as factors? No, which is false. You now say false. These are other parameters you can type along to open your file. You can see it's done. So which is also saved in my customer or whatever. At the same time, if you have many files there and you don't know which one you want to pick for now, you just want to feel free yourself to open any file of your choice. The command is read.csv. You already know that it's a CSV file you want to open, but you want to choose the file.choose. I want to choose, permit me to choose the file. And then if you like, you can put all the other parameters at the back. By the side here, header is equal to true, whatever, under that separator, and all of that. But then let's say we just want to just do that. You can see that file choose itself has open and close brackets. And then it must have this double, this is closing this. Open brackets here is closing this. So once you click on this, it will fly out a dialog box for you. When it flies out the dialog box for you, you can then choose the file of your choice. So let's say I want to click on text, or I can then click on customer. So that way you don't have to cram the name of file you want to open. Once you click on that, it's already open. But then it will only open into the screen. If you want to save it in another file in a given container here, like a variable name, you can say my customer2 assignment statement and say read into that. So you have to still choose that file again and say customers. Before you know it, will fly it out here. My customer2 is there. The same number of observations. Now, fine. So let's say you now want to do you can do some money. Now that you now have your data here, you can do so many things with your data. Let's say for all the variables, you want to get the summary of all the variables. You want to get a summary, statistical summary. Summary of all the variables. You have stored it in my customer. Is that not? My cost, let's say either one or two, whichever one we use is the same. It will give you the summary of all the attributes. Like for example, now it's giving us the summary of customer ID, which means the minimum is 1.0 and the maximum is 2.0. This is to inspect your data. And then the median is 1000.5. The mean is what you have there as well. Then we have the gender, the summary for gender as well. We have the summary for age. You know, if you look at that age, we have the minimum is 0 and then the maximum is 99. You can see all of a sudden, or not even all of a sudden, at a glance, you can say that, oh, the minimum age recorded in this data set is 0. And then the maximum, we don't have anybody that's up to 100 years. So from here, you can see that. So the one single command can do that for. At the same time, like I said, if you just want to reference one single, you want to reference my customer, you want to reference, excuse me, you want to reference any of the attributes or any of the columns, you put colon, you put $sign at the back and then over to whichever one you want to reference. Let's say I just want to check the work experience. You just press enter to see the work experience. And at the same time, like I said, you can also plot this work experience. Plot. Put it in open and close bracket and see the plot, the scatter plot on the graph chart. You know, you can also draw lines by say lines for that particular variable and then see what you have the output there. You can do the same for another variable. Let's say we just want to see you want to see another variable or maybe two variables. Let's put two variables together. My customer to $sign, let's say the age. You want to see the lines for those two. There you go. And then you also want to see you want to plot. Let's do a plot, a scatter plot. And there you go for the two of them, and a number of things like that. You can also do summary of each of these variables. You can do summary for each of the variables and any other thing you intend to do with it. So this is where we're going to stop today.